So this question says a rubber block weighing 12.37 newtons is pushed with a force of 0.76 newtons to the right. If the block accelerates at 0.5 meters per second squared, what is the magnitude of the force of friction? Okay, so let's write down what we know. We know the gravitational force, or the weight, is 12.37 newtons. We know that the applied force, right, we're applying a force of 0.76 newtons. We know that the acceleration is 0.5 meters per second squared. They want to know what is the magnitude of the force of friction. So we want to know what F is. So we have a block, and we're saying that it has a weight of 12.37 newtons. This person comes along, doesn't matter, maybe it's me. I'm coming along and I'm pushing this block with a force of 0.76 newtons. And that causes this thing to accelerate at 0.5 meters per second squared. So now that I'm accelerating this block, right, we have to find out what the force acting against me accelerating it is. We have to find out what this frictional force acting against my pushing is. Now your first thought might be to use this. FF equals mu times Fn, where mu is the coefficient of friction. Right? That might have been your first thought. And it says a rubber block weighing 12.37 newtons. So you're like, cool. I know the material of this block. So all I have to do is look at my reference table, look at this little table right here, and I can find out what this is, and I know what this is from the gravitational force, and I can solve it. That's not what you have to do. Sure, they tell you it's a rubber block, but what they don't tell you is which material it's on. Are we rubber on concrete? Are we rubber on asphalt? Are we rubber on ice? I don't know. So we can't really use it. Right? We can't just take a guess and assume, yeah, it's on concrete. We can't do that. So this is actually completely useless to us. This whole table right here, we can't use it. We can't use the value of mu to find our frictional force. What we have to do is we have to use the net force to find the force acting against us. Remember what the net force is. It's the sum of all forces. Sum of all forces acting in one dimension. So if we can find the sum of this plus this, then we can find out what just this is alone. Right? If we know what they are together, we can take this away and find out what this is. So what is our net force formula? F net equals mass times acceleration. Another problem, they didn't give us a mass. That's okay. They gave us a gravitational force. Fg equals mg. Gravitational force equals mass times gravity. So gravitational force, which is 12.37 newtons, equals mass times 9.81 meters per second squared. So to find mass, all we have to do is divide both sides by 9.81, so 12.37 divided by 9.81, and we find mass is 1.26 kilograms. Okay, now we know mass. And we also know the acceleration, 12.6 kilograms times the acceleration, 0.5 meters per second squared. And we find out that the F net, let's see, is about 0.63. 0.63 newtons. So what does that mean? That means that the sum of all of your forces in the x direction should be 0.63. So 0.63 newtons is the sum of this and this. This frictional force plus this applied force gives me 0.63. So let's find out what that is. 0.76 newtons, the applied force, plus the frictional force, which I don't know, subtract away that 0.76, and I find that the frictional force should be negative 0.13 newtons. And that's your final answer.